How does a machine predict the future? It's not magic, it's machine learning. From the song that plays next in your playlist to groundbreaking scientific discoveries, this powerful technology is quietly reshaping our world, one data point at a time. But what is it really? How does a computer learn to think, predict, and even create? Let's break it down. At its heart, machine learning is all about learning from the past to make informed decisions about the future. Imagine you want to teach a computer to recognize a cat. You wouldn't write millions of lines of code describing every possible cat. Instead, you feed it a massive data set, thousands upon thousands of images, each one labeled as either cat or not a cat. This is the training phase. The machine analyzes this data, searching for patterns that consistently define a cat, like pointy ears, whiskers, and a specific eye shape. This process relies on algorithms, which are like recipes the machine follows. With supervised learning, it learns from labeled data, like our cat example. In unsupervised learning, it finds hidden patterns in unlabeled data, grouping similar items together on its own. And with reinforcement learning, the machine learns through trial and error, receiving rewards for correct actions, much like training a pet. Once a model is trained, it's ready to make a prediction. This happens in a few key steps. First, the model performs feature extraction. When you give it a new, unlabeled picture, it doesn't see a dog or a cat. It sees a collection of pixels, from which it extracts key features: the curves of the ears, the texture of the fur, the distance between the eyes. Next comes modeling. During its training, the algorithm built a complex mathematical model that represents the relationship between these features and the final label. Think of it as a line drawn on a graph that separates all the cat data points from the not cat points. Finally, there's inference, or the prediction itself. The new image's features are plotted on this graph. Whichever side of the line it lands on becomes the model's prediction. The same principle applies to more complex tasks, like forecasting a stock's price by analyzing historical trends, market sentiment, and trading volumes. The applications of this technology are already all around us, and they are truly transformative. In medicine, machine learning models analyze medical scans like X-rays and MRIs, helping doctors detect diseases like cancer at earlier, more treatable stages with incredible accuracy. Every time you browse an online store or streaming service, sophisticated recommendation systems are at work. They analyze your past behavior, what you've watched, liked, and purchased, to suggest new products or movies you're likely to enjoy, creating a deeply personalized experience. Even the weather forecast you check every morning is powered by machine learning. These models process immense volumes of atmospheric data from satellites, weather stations, and ocean buoys to predict complex weather patterns with increasing precision. Machine learning is not just a tool for automation. It's a new way of solving problems. As this technology continues to evolve, it will become an even more powerful partner, assisting us in tackling some of humanity's greatest challenges. From climate change to personalized education, the journey of machine learning is just beginning, and understanding its core principles is the first step toward harnessing its incredible potential. What will we teach machines to do next?